All right, so today we're gonna look over Pizzazz Puzzle. Page 75. So I'm gonna do almost half of your homework with you today. It's brand new information to you, right? So the question is, what do the fans sing at University of California football games? So, you're going to come up with the question down, or the answer down below. All of these questions on here deal with rate times time equals distance. So I want you to write up here at the top, rate times time equals distance. We will use that formula for every single problem. I'm going to show you a way that you can organize your information into a chart that will tell you what the equation is to solve. All right, so let's start with question, which one do I want to start with? Let's start with A. I'm going to start with this one here. Two trucks left Buck's trucks traveling in opposite directions. One truck traveled at a rate of 70 kilometers per hour, the other at 80 kilometers per hour. After how many hours were the trucks 900 kilometers apart? That's a lot of information they threw at you, correct?
Yeah.
All right, so we're going to do the four-step plan. Take my bracelet off, or it's going to annoy the heck out of me. All right, so draw your 4 boxes. In this box, we're going to draw a picture of what's going on. So it says 2 trucks left Buck's trucks traveling in opposite directions. So if I put Buck's trucks here in the middle, I have 1 truck going this way and 1 truck going this way. Isn't that what it's telling you? I'm going to call this truck truck A and this truck truck B. But they both left the same place going in opposite directions. 1 truck, we'll say that's truck A, traveled at a rate of 70 kilometers per hour. So I'm going to put 70 kilometers per hour here. And the other truck, truck B, left going 80 kilometers per hour. And all together, we don't know how many hours they traveled, they end up at 900 kilometers apart from point A to point B, wherever they end up. Would you say that the distance from the middle here, Buck's trucks, to point B is going to be the same as the distance from Buck's trucks to point A? Are the distances here going to be the same or different? Different. Because one's going faster than the other and they go the same amount of time, right? Doesn't that make sense? So their individual distances are different. And that's going to be important for you to determine that. Are the distances the same or are they equal to each other? So then in the second box over here, I want you to create a chart. We're going to have truck A and truck B. I'm going to create a table that has 2 rows and 3 columns. We'll always create 2 rows and 3 columns for these problems. At the top of the columns, I want you to label them as rate times time equals distance. And you're going to fill in that table what you know. Do you know the rate of truck A? What did we say it was? 70. So you're going to put a 70 in there. Do you know the rate of truck B? Look at your picture. What's the rate? Rate is always in miles per hour, kilometers per hour, something like that. That's your rate. So isn't it 80? Do we know how long truck A drove? Do we? We have no idea how long, right? Did truck A drive the same amount of time as truck B? They left at the same time, going different speeds, and they ended up here, so they stopped at some point. They ended up 900 kilometers apart. Did they travel the same amount of time?
Yeah.
Yes. Do we know what that same amount of time is? That's our unknown, isn't it? So our unknown is the time that truck A and truck B travel, but they're both X because they both travel the same amount of time. Sometimes they'll travel different times, sometimes they'll travel the same time. You will always calculate this column here. 100% of the time you will calculate this column. So I specifically had you put up here at the top, rate times time equals distance. So you're gonna calculate the distance by taking the rate times the time. So what's 70 times x? 70x. And then 80 times x? 80x. What information from here have we not used here? The 900. The 900 is the distance from where truck A is to where truck B is. This is the distance of truck A. Doesn't that represent the 70x here? From here to here? And this is the distance of truck B, so this is 80x from here to here. Together, they equal 900. So what I would like you to do is, you're gonna have some total down here. We're not always gonna fill out every single box down here with the total, but I know that the total distance is 900 kilometers. This is my equation to solve. Looking at your picture here and here, what's the equation for the distance? Well, we're gonna write it out as 70x plus the 80x is equal to 900. Because Jack said 150x, where did he come up with that? Yeah, he added, aren't these like terms? Right? So now you're gonna start using your algebra. So you've taken away the story, and all you have left is the algebra. So 70x plus 80x is 150x equals 900. Do not lose that equal sign, right? Then how do you solve for x? So divide both sides by 150. So you get x equals. Don't the zeros on the end cancel out? For every zero on the end of a number in a fraction, you can cancel a zero on the end of the number in the denominator, right? So you're really taking 90 and dividing it by 15. How many times does 15 go into 90? It goes in there 6 times. What unit of measure is attached to x? Go back to your table. What does x represent? Time. So what unit of measure? Because your rate is in kilometers per hour, right? If your rate were kilometers per minute, would your time be in minutes? But because it's kilometers per hour, you need to put hours there. Now we found x, but I have no idea what the question asked for at this point because I forgot what the question was. So go back and look at the question. The question says, how many hours were the, after how many hours were the trucks 900 kilometers apart? Did we answer the question with x? Yes. So therefore, those of you who are new, a triangle with dots means therefore. So therefore, the trucks were 900 kilometers apart after 6 hours. So then, go to the bottom. And that means that A is 6, right? So go to the bottom down here and find 6 hours. Here's 6 hours and put an A above it. So we've got part of the answer. Then I'm going to do question Y with you. So that's the one to the right. This one's slightly different. A and Y are similar, but tell me what the difference is between the two. Two jets are traveling toward each other and are 4,000 kilometers apart. The rate of one jet is 100 kilometers per hour faster than the rate of the other. If the jets pass each other after 2.5 hours, what is the rate of the faster jet? How are they different?
Okay, sorry, I have a question.
What's your question?
Do it, like, you know, we did the drawing in the first one.
Mhm.
Does it have to be that order every time the boxes? Does it
Yes.
matter? Okay.
You mean rate times time equals distance?
No, like, does it matter what you put in each box?
Oh, you mean could you have put the 80 and the 70 in different boxes? Is that what you mean? Are you asking could you have switched these around?
No, I mean, like, could the information in that box be the box under it? Does it matter, like?
This whole row could be down here and vice versa.
Please
Oh,
feel how long.
oh, you mean how I arranged it here?
Yeah,
No, I want it done this way.
Okay.
There's a reason for my madness. Because these need to be vertical to each other because it's where most of your work comes from. So yeah. So, and we're gonna start here, and this is where our answer is. So the only way we're gonna be vertical is over here, because we go from left to right.
Okay.
That's just the madness for how I set it up. Because otherwise, if you put like this over here, and you try to work this way, you will sometimes lose your work because you're working sideways instead of down. Now I understand. All right, so we ready to do Y? How is Y different from A? They are going toward each other. So A was motion in opposite direction. It's your motion in opposite direction is what they'll call it. Whereas Y is motion in the same direction. So if you want to put here, for your note purposes, motion in opposite direction. And then when we set up the other one, we'll put motion towards each other, I guess. Technically, they're still in opposite directions, but these ones are going out and this one's going to go in, right? So I guess technically this is still motion in opposite direction, but they're just going towards each other. So when you draw your picture, two jets are traveling toward each other. So here's the point at which they're traveling towards. And I'm going to name one jet A and one jet B. And it says that they're 4,000 kilometers apart. So 4,000 kilometers will be the distance from here to here. From this point to this point. It says the rate of one jet is 100 kilometers faster than the rate of the other. What don't we know? The rate of the other jet. It doesn't matter which jet you consider the other jet. When we don't know something, what do we let it equal? X. So if the rate of this jet is X, what would you say the rate of the other jet is? X plus 100. And so these are in kilometers per hour, and this is kilometers per hour. And I put parentheses around the X plus 100 because that whole thing represents a value for that rate of that jet, and it's in kilometers per hour. So it's a little bit more complicated rate than the one above. So the one above was just straight numbers, right? All right, then it goes on to say, if the jets pass each other after 2.5 hours, so it is also 2.5 hours, the planes, don't they travel the same amount of time? Do they travel the same distances? Are they going the same rate? No. They're going the same time, same amount of time, but different rates. Are they going to travel the same distance or different distances? Different distances. So this one's going to be similar to the one above in the sense that I'm going to take whatever this distance turns out to be and add it to that distance, and shouldn't it equal the 4,000? So we're going to set up our chart. So we've got jet A and jet B because they want us to find the rate of the faster jet. It's kind of important that you determine what you're looking for. Well, maybe not. We'll deal with that when we get there. So rate times time equals distance. Is there any other way that I could have set this up? Could I have let this one be X? Could you have had one that was X and one that was X minus 100? Could you? Would they have 100 miles or 100 kilometers per hour difference in the jets? Yes, you could. So which is the faster jet here? The one on the left or the one on the right? Yeah, you do, just by looking at the expressions. Which one's bigger? The one on the right, right? But what if I did X and what if I did X minus 100? Which one would be faster then? The X jet, right? So there are two different ways you could set this one up. We tend to like addition, so most of you will tend to set it up this way. All right, so jet A, I know its rate. Well, I don't know its rate. I know its rate is going to be X. And I know that jet B's rate is X plus 100. Do I know how long jet A flew? What? 2.5 hours. And do I know how long jet B flew? Same or different? Same. 2.5 hours. So those are the same. And then remember, you're going to calculate this column right there. So what's X times 2.5? 2.5x, and then for our purposes here, I want you to write that this is 2.5 parentheses x plus 100. We will distribute that in a minute. Are these distances the same or different? If they're different, you better have a total distance down here. Do we know the total distance that the planes are apart? Don't we know it? 4,000. If they don't give you a total distance, then the distances are probably equal, and we'll look at one in a minute. this is your equation to solve. This final column is your equation to solve. So we're gonna set up, wouldn't it be this distance plus this distance equals the 4,000? This distance plus this distance equals 4,000. So 2.5x plus 2.5 parentheses x plus 100 equals 4,000. Don't let the big numbers bother you. What do you do first? Yep, distribute first. So now we're not talking about the store anymore, we're just doing the algebra. So 2.5 times x is 2.5x. 2.5 times 100, how do I do that easily in my head? Okay, so 100 has how many zeros attached to it? 2. So that means I'm going to move this decimal place 2 places to the right because I'm making it bigger because I'm multiplying by 100. I don't have enough places to move it, so I add on a 0. Doesn't it become 250? If you don't believe me, you can do it out longhand. Equals 4,000. Now what do I do? What do you know about those? They're like terms, right? What do they add up to? 5. So don't I have 5x plus 250 equals 4,000? Our decimal is now gone. Chew, right? What do I do? Subtract 250. So you get 5x is equal to 3,000, what? 750. Then what do you do? Divide by 5. So x is equal to, 5 goes into, you can do shorthand division or do it longhand out. You decide. But if you want to know how to do shorthand, 5 goes into 37 how many times? 7 times. What's 7 times 5? What's 37 minus 35? So put a little 2 here. 5 goes into 25 how many times? 5. What's 5 times 5? So nothing's left over. So how many times does 5 go into 0? 0 times. There's your shorthand division. Or you can do it all out long the way. So I found x. Again, go back to your chart. What does x represent? Rate. And rate is in what units of measure? Kilometers per hour. Now the question asks, what is the rate of the faster jet? Is x the faster jet? No. X plus 100 is the faster jet. So what is x plus 100? What's this plus 100? 850. So that's the answer that we want. So therefore, the rate of the faster jet is 850 kilometers per hour. So answer that question with a complete sentence. Then go down to your answer, find 800 kilometers per hour right here, and what are you going to put above it? OY. So you have AY. Okay, so you've got 2 that are like that. Then I'm going to switch up a little bit, and I'm going to go and do S with you. So I'm going to flip this. So let's look at S as in Sam. So S says, Ms. Drive-a-Wreck drove from her home to a service station at 48 kilometers per hour. So she drove from her home to the service station. She returned home by bicycle at 16 kilometers per hour. Did she go the same distance or different distances? She went from home to the service station back home. So each leg of her journey she went the same distance, didn't she? So this is different than the first 2 that we did. The first 2 that we did, they went different distances. Now we're going the same distance. The entire trip took 4 hours. Now they're telling you the total amount of time, not the total distance. I don't know how long it took her to get to the service station. I don't know how long it took her to go from the service station to the house, but what I do know is it took her a total of 4 hours. The question is, how far is the service station from Miss Wreck's home? So let's draw a picture of what's going on. So here's her home, and here's the service station. So the first leg of her journey, we're gonna call 2. She went from her home to the service station. What do we know? What information did they tell us about that leg of the journey? She drove, and how fast? 48 kilometers per hour, right? Then her second leg of the journey, we're gonna call from. She went from the service station back home. What do we know about that? She took her bicycle, and it was 16 kilometers per hour, which makes sense that if you're riding a bike, you go slower. You can see by your picture that it's the same distance, right? So equal distances. That's important to note because that's how you set up your equation to solve. You're either going to add your distances together and set them equal to some number, or you're going to take your distances. Do you need to go stand up in the back of the room?
No.
Then I would suggest you don't lean on your desk because you're falling asleep. So get your arm off the desk and sit up straight. There you go. There we go. Or in this case, we're going to end up setting our distances to the service station and the distance to home equal to each other because they're going to look different, but they're going to be equal distances. What else do we know that they gave us? Total time was what?
4 hours.
Okay, so now I'm ready to set up my chart. So my chart is to and from. I still have rate times time equals distance. We know our rate to the service station was 48 kilometers per hour. Our rate from the service station was 16. I know that my total time is 4 hours, so that total time goes here at the bottom of this. I don't know how long it took to go to or from. That's our unknown, isn't it? So if I were you, I would assign, I don't know, it doesn't matter which one. Assign X here or here, it doesn't matter which one. If this is X hours, what's this one gonna be? Let me just tell you, what if this were 1 hour? How would you know what this is? If this were 1 hour, what would this be? 3, how'd you get that? You subtracted 1 from 4. If this is 2 hours, what's this? 2. If this is 3 hours, what's this? 1. So if this is X hours, what's this? 4 minus X, right? Because this is the total number of hours. Whatever this turns out to be, we'll subtract it from 4. So that's how we use that 4 hours. And you're going to have another couple problems where you have the total time, and you've got to let one be X and one be 4 minus X. If you switch these two around, would it make a difference? No. If you switch them around, your X is going to be different from my X, but we'll still get the overall same answer. Because obviously, since they went different speeds, these have to be different times here, right? So if you have a friend that switches them around, your X's will be different, but your overall answers will be the same. Remember, don't you calculate this column here? You always calculate that column. So what's the distance to? Calculate rate times time. 48x. And then this one I want you to write as 16 parentheses 4 minus x and parentheses. Notice that there is no total distance here. I know nothing about the distance to the service station or from. The only thing I know is that the distances are equal. So I'm going to put a little equals sign right here. If there's nothing here, you will set the distances equal to each other. Okay? And so here we go. 48x is exactly equal to 16 parentheses x minus, 4 minus x. Now we're going to solve. What do you do first? Distribute, right? So we have 48x equals, what's 16 times 4? 64. 16 times negative x, watch your signs, negative 16x. Now what do you do? Yeah, you want to get your x's together. This is a smaller x, right? You don't want to lose your equal sign, so add 16x to both sides. What is 48 plus 16? 64x is equal to 64. Now what do? Divide by 64. What's anything divided by itself? So x is 1. Go back to your chart. What unit of measure is attached to X? Hours, because it's time, right? So this is 1 hour. I forgot the question. So go back to your problem, look at S. S says, how far was the service station from Ms. Reck's home? Here's distance. Does it matter whether I plug it into here or here? Aren't these the same? This is from her home to the service station, and this is the service station to her home. Which one would you rather plug it into? I'd rather plug in the first one. So we're going to take the distance, which is equal to 48x, and we're going to plug in for x 1 hour. And because it's distance, isn't it going to come out to be 48 kilometers? So therefore, the distance from Ms. Reck's home to the service station was 48 kilometers. So go back to your thing at the bottom, find find 48 and put an S there. So we have the word say so far. And the last one I'm going to do with you is N as in Nancy. Question?
I was just trying to get that.
Say that again?
You can just leave it out.
I will. Yep. I thought you had a question on the other one. All right, so look at N. N says, Steve McSpoke left home on his bicycle at 8 o'clock a.m., traveling at 18 kilometers per hour. At 10 o'clock a.m., so what's the difference in time? How many hours difference? 2 hours later, Steve's brother sets out after him on a motorcycle following the same route. So this is motion in the same direction. So prior to this, it's really been motion in the opposite direction. So this is the only one that I've done with you that's motion in the same direction. So he's following on a motorcycle. The motorcycle travels at 54 kilometers per hour. How long had Steve traveled when his brother overtook him? So here's a picture of what's going on. So we have here's the home, and then Steve is going in this direction, right? So this is S, Steve. He's going in that direction. But I don't know do I know how long he travels? Do I know how long? All I know is he left at 8 a.m., right? So far. And then his brother starts out at the same place, going in the same direction. This is his brother, his bro. But he starts 2 hours later at 10 o'clock a.m. Do I know how fast Steve is going? Do you know how fast? No, Steve. Steve is going 18 kilometers per hour. What's his brother going? 54 kilometers per hour. Will his brother eventually overtake him? Eventually, they're going to come to this point where his brother is going to overtake him, and they're going to be at the same place at the same time, right? Will they have traveled the same distance or different distances at this point in time? At this point in time, they left from the same place and they ended up at the same point, right? Wouldn't this be the same distance? Right? I don't know what distance it is. I can figure it out in a minute. But it will be the same distance, won't they? Will they have traveled the same amount of time? No, because they're traveling different rates, but the same distance. So they couldn't have traveled the same time. What I do know is that his brother traveled how many hours less than Steve? 2. Or Steve traveled how many hours more than his brother? 2. You can look at it either way. So let's set up our chart. So we've got Steve and his bro. And we've got rate times time equals distance. We know Steve's rate is 18. We know his brother's is 54. We don't know total time. So here's the deal. The question says, how long had Steve traveled? How long? Isn't that time? Since we want to know how long Steve had traveled and we don't know it, what should I let it equal? X. If I let Steve equal X, I could let his brother equal X, but if I let Steve equal X when I solve for X, won't I have answered my question? That's why I'm choosing to let Steve be X. Then, did his brother travel for more time or less time? Less time because he left 2 hours later, right? So what is his brother's time? X minus 2. Does that make sense? His brother left 2 hours later. If I had let his brother be X, what would you have let Steve be? X plus 2, because Steve went 2 hours more. So there are two different ways to set this up. Again, as we've done all along, you will calculate this column. Have you been given any information on total distance down here? No, and there's a reason for that. If you're not given that information, then they're the same distance, and you're going to set the distances equal to each other, right? So what's Steve's distance? 18x. And then his brother's distance is 54, parentheses x minus 2. So now we're going to solve that equation. 18x equals, because they have the same distance, 54 times x minus 2. Don't we distribute first? So 18x is equal to 54 times x is 54x minus, what's 54 times 2? 108. Now what do I do? Okay, so my like terms are 18x and 54x. This one's smaller, right? So I would be subtracting 18x from both sides. What does that leave you on the left? Everything cancels out. What are you left with? 0 equals, what's 54 minus 18? We'll borrow, right? What's 14 minus 8? So don't you get 36? X minus 108. Now what do you do? Add 108. So we have 108 equals 36x. Now what? Divide by 36. So x is equal to, well, if you don't want to make an educated guess, about how many times does 30 go into 100? 3. So off to the side here, take 36 and multiply it by 3. What do you get? You get 108? Okay, so isn't x equal to 3 then? And go back to your chart. What unit of measure is x? Hours. So x is 3 hours. That means Steve traveled 3 hours. What did his brother travel? What's 3 minus 2? 1 hour. So how far did his brother go? If he went 1 hour, what's 1 hour times 54? Didn't he go a distance of 54 kilometers? Doesn't that mean Steve went 54 kilometers? Is that the question that they're asking for, though? They're asking for how long had Steve traveled when his brother overtook him. So, therefore, we answered the question when we solved for x. Steve had traveled 3 hours when his brother overtook him. So then take your answers at the bottom and find 3 hours and put in n here. All right, so you have half of them done. This one right here, I don't really count that as a full problem. That one will not be the 4th step. Because all they're saying is in exercise N, how far had Steve traveled when his brother overtook him? Didn't we just talk about that? So if Steve's distance was 18x and you found x to be 3, for this one, wouldn't you just take 18x equals 18 times 3? What do you think 18 times 3 is? It's that 54 kilometers. So for 54 kilometers, put in C. So now we've done over half of them. So all you have left would be, what, O, and U, and A, and this other C. This one is much more difficult, but draw your picture. You've got 15 minutes. I'll happily help you. In that 15 minutes, you should get at least 3 out of the 4 that's left done.